And for our next talk, I'd like to welcome on stage Jeroen to Schiphorst. He's a startup entrepreneur who joined Clearvue as Chief Chemical Technology after acquisition of the assets from his startup, Lesoko. I hope I pronounced that correctly. Jeroen founded his first company while completing his PhD in chemical engineering and chemistry at TUE, and his expertise in both the characterization and application of dyes and luminescent solar concentrators and in microfluids. His focus is on progressing the development of the fluorescent ink technologies, as well as assisting integration of the technology with Clearvue's own solar glazing solution for bus shelters, public advertising, and signage applications. Jeroen, the floor is yours.
Thank you for giving me this audience. I'm quite flattered to be talking here to some of the biggest experts in the field of glass. And today I would like to take you on a journey on highly transparent glass that is able to generate energy. And I think Miles already gave a beautiful couple of examples why the necessity of these applications is really important. Well, when I woke up this morning, I checked my phone to see what the weather would be like in Finland. And I always thought that this was quite a cold country. But I was quite shocked to find out that it will be 28 degrees today. I think that nicely shows that we actually have a climate problem and that we have to take care today. Of course, solar cells are a great way to harvest energy, and you will probably hear it a couple of more times today that 40% of the energy consumption worldwide is coming from buildings. We can really make a huge impact there. Europe already set an example that as by 2021, all new buildings have to be net zero energy consumption. That means that they have to generate some of their own energy or get their energy from a sustainable source. Now, if we take a look at an example of a building on the left, solar cells on roofs is something that we know very well. You might have them at your house, but the moment you go into high-rise buildings, you will find that the surface of a rooftop often is very limited, and it is insufficient to generate enough energy. Of course, there are other opportunities, because we also have large facades. And here you can see an example of Studio Solarix from the Netherlands, where they managed to incorporate solar cells on a facade, allowing you to create something that is aesthetically pleasing without you noticing that there are actually solar cells. But of course, today we're at the Glass Performance Days, and we all love glass, and we also should be doing something with that. And one of the main functions of glass is not it's creating an outer shell to the outer world and the inner world, but the most important part of glass is actually to create transparency, to allow you to look at the outside world and see what's going on there. And that brings us to a paradox between efficiency and transparency. On the left side, you can see a classical PV module, and one of the reasons why they work so well is because they're able to absorb a lot of light. They're completely intransparent, and it allows you to generate energy. But as I just said, facades, glass, their main function is actually to look outside. So we get into a paradox there. Well, some of the examples that you will find is laminating solar cells in between glass, for instance, which is a great opportunity if you start charging your car at Fastnet, and it will allow some of the light to pass through, so it provides shading as well as energy harvesting. But as I said, for most applications, remaining fully transparent is really key to have this technology adopted in your windows. At Clearvue, we cracked the code to do so. We are able to create truly transparent windows that have a transparency up to 70%. And to place this within perspective, if you take a triple glazing unit, this is about the value that you get there. While being 70% transparent, we're still able to generate 30 watt peaks per square meter. Now, how are we able to do that remaining so transparent? We make use of 3 different principles for energy harvesting. The first one is making use of the UV part of the light, the part that we cannot see. The UV light is being absorbed by the nanoparticles and microparticles that we embed within the glass, and we create a so-called luminescent solar concentrator. And I hope the people can see the picture on the bottom right here, because there is a table in front of it. But we have a glass plate, and in the interlayer of the glass plate, we're able to place these particles. These particles are able to absorb UV light, and they start emitting at a longer wavelength in the form of fluorescence. And because we can do that laminated between glass, we create a so-called waveguide. The high refractive index of the glass results in the light being transported via total internal reflection to the edge of this glass. And on that edge, you can place small solar cells, and that concentrated bundle of light there is being harvested in the form of energy. That's the first way of generating energy. The second way that we use is making use of scattering particles that are able to scatter the infrared light and again make use of that total internal reflection, that waveguiding function of the glass, to concentrate that bundle of light that we get to the edges. The third way is rather simple. The third way that we use is creating a rim around the window, where we also place some solar cells in there that are able to absorb directly the sunlight that is hitting these solar cells. And making use of those three principles, we're able to get up to 30 watt peak per square meter. Now, of course, getting a window, it's also important to be able to scale, and that's exactly the reason why we decided to go for an interlayer to have these particles in there. We can go up to 1.60 m by 3 m already, and that is simply because we embed these particles within the interlayer, and those processes are very well known to the glass industry to laminate these glass plates. As said, we therefore are compatible with the industrial processes. We don't have to buy our own equipment. We don't have to set up our own factories. We can work together with you to make sure that these windows can be produced. And that also results in the possibility to license out this technology. You can start providing these windows to your customer to help them better. Last but not least, to get into the market, you also need to have certification. And this sounds very trivial because there are certifications for facade glass and there are certifications for PV, for solar cells. However, combining these two products together results in a new class of materials, and that is something where certification was not done yet. We have been working over the last 5 years to make sure that we are compatible with these processes, that we have this certification, and that we can be installed already today in the window glass. I won't go over all the different certifications that we have, but be sure we are able to do it today. Of course, as every company, we started small. On the top left, you can see an example of glass on a very small size, but what you can see beautifully there are the red rims around the glass, which is the concentrated light that we're able to harvest with the solar cells. After that, because we make use of this PVB materials, the interlayer materials, we can scale already to 50 by 50 centimeters. And that for us is a great way to validate the technology and to continuously improve to see if we are on the right road. But on the right here, you can see our chairman, Victor, looking very proudly at a glass pane of 2.1 by 1.2 meter. And I just previously said that we can go bigger. However, the office was not able to harness something of 3 meters, but we can go up to 3 meters in height and creating these energy harvesting windows. Well, after going through the process of laboratory testing, of doing your small-scale testing, you, of course, also have to go to the market, and this is exactly what we did. We are installed already for a couple of years within the Warwick Shopping Centre atrium, where we are able to generate energy within this part. But today, I will be focusing more on the Murdoch University greenhouse, where we converted a greenhouse into a powerhouse. And within this greenhouse, we're able to generate quite some energy, which I will show you later on. After that, this of course is a research pilot that we did together with the university. We also already get some commercial traction, and that is the Tomita greenhouse in Japan, which I will show you on a little bit later. But before going there, I would like to talk a little bit more on the greenhouse that was developed. Here on the left, you can see standard windows, which are laminated glass panes, and you can see them here as a reference room. On the right side, you can see 3 individual rooms that are the same size as the one on the left, where the solar glass is installed. And you can see here, you can distinguish them only by the black rim around it, which are the solar cells. Next to having solar glass in the facade, we also included the solar cells on the rooftop to find out what's going on with different orientations. Because having glass on one orientation is not fair, you of course have a building that has multiple areas where you have to have this glass. To do so, we also installed the glass on the sides of the greenhouse, but also on the back to get information on all the different orientations where we are able to harvest energy. And next to that, you can see that it is quite a high-end greenhouse. So you can see the technical room here with, for instance, the installations for the air conditioning that is in there, the watering systems, as well as the measuring systems to validate what we are doing within this greenhouse. Now, as it is a greenhouse, it's only fair to also place some plants in there. So we are able to generate crops there, and we are also doing studies to find out how well this crop grow is going and if we see any influence of the glass in the field of yield of the crop growing. And as I said, we have 3 ways of generating energy, one via the particles and the light conversion, one via the scattering, and the third way being the solar cells that are present within the window, which you can see here on the edges. With that, I would like to go to some data to show you that this is really working. We make use of triple glazing, and that allows us to create also some nice insulating properties. So if we take the orange line as the first one, which is our control room, and we switch off the air conditioning, we can look at what's happening with the temperature. And what you see there is that the moment the sun starts hitting the glass, the temperature increases really rapidly within this greenhouse. And you can see that it is increasing to about 35 to 40 degrees. After that, you can also see that the temperature, the moment that the sun starts rotating, is decreasing quite rapidly and is going to a temperature which can be seen as quite cold for some plant growths. Now, if you make use of the Clearvue windows, what you can see is that the jump in temperature is far less steep. And you can see that the maximum temperature reached within this greenhouse is a little bit lower. Next to that, you can see that the temperature is being retained over a way longer period. Now, if we translate this to energy consumption, it means that we need less of an air conditioning to cool down this greenhouse if you are in a hot climate. But if you're in a cold climate, you actually need less of heating to have this greenhouse performing well. Next to that, we also checked what's happening if we compare our technology to standard photovoltaic cells which are optimally tilted. Now, for those who are still looking very closely at this presentation, I just said optimally tilted, they're in the northwest. Well, of course, we're an Australian company, and we're on the other side of the world, so that actually means that the sun is coming from the other side of the equator. So northwest, you have to believe me on this one, is actually optimally tilted in Australia. Next to that, you see April to June. You might be thinking we're heading towards summer. Actually, in Australia, we're heading towards the winter. You also see that back in the energy performance of both systems, where you can see a decrease in the total amount of energy because it's becoming winter, but you can also see that our multi-oriented facade is actually nicely following the solar cells that are on the rooftop. And that means that even although some of our solar cells are vertical, some of them are under different orientations, we're able to generate energy in very many directions compared to a solar cell which has to be pointed towards the sun to be efficient. And I think this graph actually shows it all. Making use of the energy harvesting within this greenhouse allows us to create an offset of 40% of the required energy. We're able to generate 40% of the energy that is needed simply by changing the walls and the roof towards solar glass, which is not impacting the crop grow at all. Well, after that, it's a research facility. It allows us to monitor the technology. It allows us to look at what's happening at the crop grow. But it's also important to get commercial traction as a company because we were able to prove that it's working and to get the technology out there. And we're working with a Japanese company that over the last 15 years has implemented 250,000 square meters of greenhouses, where you can see that there is a huge potential to change this glass towards energy harvesting glass. And what you can see here is that all the walls of this greenhouse are made of this energy harvesting glass. And with that, we're able to generate about 28 watt peak per square meter in a large area. With that, I would like to conclude my presentation. And what we showed is that we're able to generate energy from a greenhouse, but this greenhouse can be easily converted into facades. We are ready to take the next step. We need you to start helping us to implement this technology further, so that we can actually create an energy harvesting skill all around the buildings in the world. With that, I would like to end with the message that we always say at Clearvue, and I would like to invite you to also say hello to solar glass. Thank you for your attention.